Hello guys, in this video we are going to discuss the solution of the problem print matrix in diagonal pattern. So let us look at the problem statement. The problem statement says that we are given a square matrix mat and of size n by n. The task is to determine the diagonal pattern which is a linear arrangement of the elements of the matrix as depicted in the following example. So let us try to understand the problem statement with the help of an example. So let us say a matrix is given to us of size n where n is equals to 5. So the matrix which is given to us is of dimension 5 by 5. So let us say that this is the matrix which is given to us. So let us say this is the matrix which is given to us and we would like to diagonally trace this matrix and print the matrix in the diagonal fashion. So initially we are going to trace this matrix in this way. So in this diagonal there is just one element which is 1 itself. So we are going to print 1. Then we are going to traverse the next diagonal which is this, and we are going to traverse in this order. Please note the direction of the arrows. In that direction we need to traverse. So after 1 the next element will be 2 and then 1. After that, again we will go ahead and traverse the array in this way. So here the elements would be 1, 2 and 3. Similarly, let us proceed further. So this is how we are going to traverse the matrix, and this is what we would like to return. So that's about the problem statement, folks. Now let us go ahead and discuss the solution for this problem. So here we would like to iterate the elements of the matrix in the diagonal fashion, and while iterating we would also like to flip the direction. So here this is the direction, whereas over here this is the direction, and over here this is the direction, and so on for the rest of the diagonals. So from here what we can understand is we need to write a separate logic for yellow diagonals, and then we have to go ahead and write a separate logic for orange diagonals. So now let us see how we can go ahead and write the separate logic for yellow and orange diagonals. So let us first go ahead and talk about yellow diagonals. Firstly, let us go ahead and number each of these diagonals. So this is my diagonal number 1, this is my diagonal number 2, 3, 4 and so on. So these are my 9 diagonals which I have. Of these 9 diagonals, I can say that yellow diagonals are odd numbered diagonals. Now the next step is we would like to find out the starting position of each of these yellow diagonals. So in order to find out the values of I and j, let us go ahead and list down the diagonals which lie in yellow category. So these diagonals are 1, 3, 5, 7 and 9. So these are the diagonals which lie in yellow category. So let's go ahead and analyze these diagonals and see if we are able to deduce the values of I and j. So if we go ahead and analyze these diagonals, what we can say that for diagonal number 1 and diagonal number 3 and diagonal number 5. So for these 3 diagonals, the value of j is equals to 0. So for these diagonals, the value of j will be equals to 0. How about the value of I? So if we want to find out the value of I, so this is my diagonal number 1 and the value of I is 0. This is my diagonal number 3 and the value of I is 2. This is my diagonal number 5 and the value of I is 4. So what we can say that, well, we can go ahead and say that I will be equals to diagonal number minus 1. So for these 3 diagonals, we are going to go ahead and set the values of I and j in this way. Let us now go ahead and analyze for the rest of the diagonals, which is 7 and 9. So for 7 and 9, let's go ahead and analyze it. So now we are talking about these diagonals 7 and 9. So for these diagonals, we can say that the value of I is equals to n minus 1 since they belong to the last row. So the value of I is equals to n minus 1. Well, what is the value of j? So the value of j can be found out by subtracting the values of diagonal number and n. So here we can say that this is diagonal number 7 and the value of n is 5, which if we subtract 7 and 5 we will get 2, and that is the starting index of j over here. So what we can say that is this j is equals to diagonal number minus n. And this is how for yellow diagonals we will be able to go ahead and populate the values of I and j. Now the thing is, we took it for granted that we will be able to divide this diagonal into these two parts. These are the diagonals where the diagonal number is less than or equals to n, whereas these are the diagonals where the diagonal number is greater than n, right? So in this way we will go ahead and classify it, and accordingly in this fashion we will go ahead and put the values of I and j. So that's about the yellow diagonals, folks. Now let's go ahead and analyze the values for orange diagonals. So like yellow diagonals, orange diagonals are even numbered diagonals. And let us list down the diagonals which are even in nature. So those diagonals will be 2, 4, 6 and 8. So we need to work with these diagonals. And like the yellow diagonal, here also we would like to find out the value of I and j. So again, the same thing we are going to do it for orange diagonal also. So let us see what will be the value of I and j. So here also for diagonal number 2 and 4, which is less than n. So for 2 and 4, the starting position is 0th row. Since it starts from the 0th row or the first row, so the value of I will be equals to 0 for these two diagonals. What will be the value of j? Well, the value of j will be equals to diagonal number minus 1, again over here also. So now let us go ahead and analyze for diagonal number 6 and 8. So for diagonal number 6 and 8, what we can say that the value of j is equals to n minus 1, since it starts from the last column. So because of which the value of j will be equals to n minus 1, and I we can express it in the form of diagonal number minus n. So this is how for yellow and orange diagonals we will be able to find out the values of I and j. And one more minor thing, folks. For yellow diagonals, if you see, in order to find out the next element in a yellow diagonal, what we need to do is, so let us take a case for third diagonal, which is a yellow diagonal. So let us say we have printed the first diagonal. Now we would like to print the next element, which is 2. So this element we would like to print. So in order to get the next element, what we need to do is we need to decrease our I by 1, and j has to be increased by 1. Similarly, for orange diagonals, if you see, so let us say we have printed this value and we would like to print the next value. So in this case, we would like to increase our I by 1 and decrease our j by 1. So here we would like to increase our I by 1 and decrease our j by 1. So that's the core idea, folks. Now let us see how we will be able to code this. So I have already coded this, folks. Now let us see how we have implemented the logic we have learned so far. So this is the answer dictionary which we will return. INC equals to 1. So folks, this is another concept which I missed to inform you. So let me just switch back and explain this concept also. So this concept is very trivial, and if you see, what we would like to understand here is what is the number of elements in each of the diagonals. So let us go ahead and populate the values, the number of elements in each of the diagonal. So in the first diagonal, as we can see that the number of element is 1. In the second diagonal, the number of element is 2. Third, 3. In fourth diagonal, it is 4, and in fifth diagonal, it is 5. Now from sixth diagonal onwards, it starts decreasing. So what we can say that the number of elements in each diagonal ranges from 1 to 5, and once it hits 5, then it starts decreasing and it goes all the way till 1. So that is what INC equals to 1 I have stored. So initially I'll go ahead and increase my number of elements per diagonal by 1, and once I will reach the number of elements equals to 5, then I'll go ahead and change inc equals to 1 to inc equals to -1, because of which I'll start going ahead and decreasing the number of elements. So with this understanding, let us now go back to our code. So this is what inc equals to 1 is, and then we have n, which is the length of the matrix, and then the number of elements initially with diagonal number 1 is 1 and the diagonal number 1 is 1, while the number of elements is in the range of 1 to n. Now we would like to find out the value of I and j and how I and j will be increased or decreased, right? So how I and j value will be increased or decreased is something which I have kept over here. And now let us see how we have find out the values of I and j. So now if it is diagonal mod 2 equals to 0, which simply means it's an even diagonal, and from our explanation, if you want to relate this, these are orange diagonals. So for orange diagonals, if the diagonal number is greater than n, then the value of I and j will be like this. Otherwise, the value of I and j is like this. And then since it is a orange diagonal, then in order to find out the next element, I have to increase I by 1 and decrease j by -1. Otherwise, for odd diagonals, my I increase and j increase will be -1 and 1 respectively. And if it is a diagonal which is less than or equals to n, then I and j are populated as such. Otherwise, it will be populated in this fashion. So after this part, we know what is the value of I and j, and we know how we would like to go ahead and find the next element also. So now let us go ahead and iterate that diagonal. So now the number of elements in a diagonal is something which is over here. We know the starting position of the diagonal, which is pointed by I and j. Once we have appended the ith and jth value, then we go ahead and find out the next element of the diagonal, which can be found out by I equals to I plus increment and j equals to j plus increment. Please note, I increment and j increment will be plus or -1. So in this way, we will be able to traverse the diagonal and we will be able to append the values in the answer array. After doing that, so this part, folks, this part is essentially once we have reached the fifth diagonal, then the number of elements per diagonal will decrease now. That is why I have set inc equals to -1, and the number of elements will be equals to number of elements plus inc. So initially it will increase all the way till n, and once it reaches n, then it will start decreasing from there onwards. And with each iteration, we will go ahead and increase the diagonal number. And towards the end, we will go ahead and return our answer. So that's the code, folks. Now let's go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.